Hi, subscribe to this channel. Go to this red subscribe and click. And you also see this bell shape. So click on this and select all. This means you would be getting notification of all videos uploaded on this channel. Cheers.
So we start the lecture today, and is there anything specific that you want to learn?
I think we just started doing anti-differentiation.
Anti-differentiation. Okay, good. First of all, let's look at what is the basic formula of anti-differentiation. Anti-differentiation. It is also called most popularly as integration. Okay, what is differentiation actually? What does a differentiation gives?
Gives the rate of change of a function.
Yeah, differentiation gives the rate of change, a rate gives rate of change. Yeah. Let's look at what integration is. Um, so if you remember, in case of in differentiation, you were looking at something like, for example, if it is there. So what you were doing was you were looking at a small change in y and you were looking at the gradient. So gradient was small change in delta y over delta x. Yeah, remember that?
Yes.
Okay. In case of integration, it's a reverse of integration, or anti-differentiation is opposite. So it's like a summing up. While here there was a difference, integration is summing up. So integration is summing up.
Yeah.
And it is a like division and multiplication are reverse process. Same is the case with the integration or anti-differentiation. It is a reverse process or a of to differentiation. Yeah.
Yeah.
Okay. Let's see how this thing. So I have opened another whiteboard. So this is our first whiteboard, and I go to the second whiteboard. Okay. Um, let's write. We know if dy. Let's say if y is equal to a x raised to the power n. So dy over dx would be, what would
Uh,
be dy upon dx?
n a
Yeah, n I.
x to the power of n minus one.
Yeah. So in fact, integration is opposite of it. So let's take a blue and we say if it's a x n dx. So the answer is a x n plus 1 over n plus 1 plus a constant. Do you know this formula or no?
Yes.
Okay, that's good. So what we are saying is, so a is a constant, so we can take the a out. So actually we are doing like this. We are taking a out, then we have this xn dx. Yeah, and then we say, okay, this is a xn plus 1 over n plus 1 plus c. C is a constant which comes in this entire differentiation. Yeah.
Yeah.
Okay. Um, let's quickly make it something like this, that if you have a function, let me take another color, and the color is something blue. If you have a function f x and it's to the power of n, and then you have a derivative of this fx dx, can you let me know what is the integration of this function?
Of dx.
This one, this function which I wrote here with the
Uh,
blue with the yellow. Any idea?
No, I'm not sure. No.
Okay. Uh, it's the same formula, but I have made it a little complex. Let's look at it, what I am going to do. Yeah, let me show it in another way. So I take another color. I take a red color. So you see, if fx is equal to x, yeah,
Yeah.
then above formula becomes what? Above formula becomes, can you take a attempt of it?
Then it's 1.
No,
Uh,
fx is equal, so we say it would become, so I am writing it here, instead of fx we have x, and then its power is n. Do you understand that?
oh, I think so. Yeah.
And then what is f bar x? Because
Uh,
fx, sorry,
f bar x is,
is derivative of x.
yeah.
It become,
So it becomes nx.
no, no, no.
Okay.
Let me ask you again. Look, if y is equal to x, what is dy upon dx?
Oh, 1.
1. So y bar is equal to 1. And here in this case, we put this f bar x becomes 1 dot dx. Yeah?
Yeah.
So what is the formula then? Then it becomes xn into dx. Yeah?
Yeah.
So what is this? Can you let me know the answer?
Would it be so just x over 1?
Uh,
Or,
look at the formula. The formulas here.
oh, okay. Yeah. Yeah. Sorry. A times.
A, there is no a here because here there is no a.
Oh, yeah. 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 Okay. Yeah.
Yeah,
So then x to the power of n plus 1 divided by n plus 1
plus c.
plus c. Yeah.
Got it?
Yeah.
So in on the basis of this, we are, so this formula which is written here, I again try to show it here. This formula where I am pointing out, it's a very simple formula.
Yeah.
What we are trying to do is make a generalized formula so that we can use it for any function. Yeah.
Yeah.
So I would take your help to write that formula very with the help of these two things which we have done. Yeah. So look at what we are doing here. Yeah. So we have to find now this formula, and it would be a generalized formula for any function. Okay. So it would become fx n plus 1 over n plus 1 plus c. You got
Okay.
this? You
Yeah.
got
Yeah.
this?
Yeah. Yeah.
So it's a generalized formula. So the first thing which we learned here was a very simple formula which only was valid for x. So this formula which we have, um, which we are, let me have another color so that I make a boundary over here. This is a very simple formula. Why? Because we were treating only x. While this formula which we have written now is a generalized formula, and it can be used for any function. Yeah.
Yeah.
Okay, let's do it in on a third. So let me take a blue. So what we have, and you should remember, try to use this formula. We said if it is like this, fx raised to the power n dot f bar x dx, this thing is equal to f n plus 1 over x. Let me, yeah, over n plus 1 plus c. Yeah, you have to remember this formula.
Yeah.
And now we would do some questions using this. Do you have any question which I want to do?
No.
Uh, let's do very simple question, and then we would move towards a somewhat difficult question what we have learned.
Yeah.
Yeah. So let's do one question which is very easy. So example one. So we would do an example. Let's say we have x. So our function is f(x) is equal to 6. Yeah, we have to define make antiderivative.
Okay.
Okay, good. We would just do that. So we have a. Can you help me writing this anti-differential equation?
Yeah.
Okay, integration sign. What should I write here?
So it's x of
Yeah,
x
x
6.
to the x to the power of 6 and then dx. Yeah,
So that equals so x to the power of 7/7.
plus c. Don't forget to write
Oh,
c.
plus c.
Yeah,
Yeah.
yeah. Okay, good. So always remember that in this case, we would talk about in some subsequent lecture why C is there, which was not there. We would talk about it. So this is a very easy question. Let's say we have another equation. So I take another color. And it is, for example, x raised to the power 5/2. So the equation becomes x 5/2 dot dx. Yeah. So actually what we are looking at it is in the same formula. If we compare this equation, if we compare this equation, this with the with our this formula, so it becomes something like so if you see what is fx then, if I am writing it like this, what is fx then? Compare our formula with this question which we are trying to do.
Uh, would it be? Do you want the answer?
Yeah, what is fx if I am comparing
Okay.
our let me if we are comparing this equation which is our generalized formula with this equation which the question which we are doing, so what is fx here then?
Fx is would be so x to the power of
No,
7.
no, not power,
Oh,
because
sorry.
power comes with n, you understand? So the power is in fact n here where I am
Yeah.
pointing out. Yeah,
Yeah.
so fx is x, do you
Oh,
understand this?
okay. Yeah, yeah, yeah. Sorry. Yeah.
Yeah, and what is n here in this equation, in
N
this
is
question?
5/2.
Very nice. What is f bar x? That is the first derivative of fx. That would be
X to the power of.
derivative.
Oh, okay. 5/2.
No. What is that? Look at here. We have fx equal to, we had fx equal to what?
X.
X. So what would be f bar x?
One.
Derivative of f. Yeah,
It'd be 1.
it would be 1. Very nice, very nice. So it would be 1. Yeah. So So let me just rub that thing because it may confuse someone. So we have now comparing this our our this question with our equation or the formula. Yeah, we would do it like this. You
Yeah.
understand this? Because ultimately you will have difficult questions. So I am trying to do it, even trying to teach you from here. A little bit difficult, but I think it would be more helpful. Yeah.
Okay.
Okay, so if we have done, so we would do. So what would be the answer then?
The answer would be x to the power of 7/2
Yeah, 5/2 plus 1. Yeah,
yeah, divided
divided
by 5/2 plus 1.
plus c. Yeah,
Yeah.
so this becomes x 7/2, and then is this thing becomes 7/2 plus c, and if we take it the otherwise, it becomes 2/7 times x 7/2 plus c. So far so good.
Yeah.